All right, we're going to continue talking about how we measure things about the stars. And we're going to talk again about how to find the distance of stars. And we said that one way to find it is parallax, but parallax can only determine the distances to a few nearby stars. Okay, now a few might be 300 or so, but there are a million stars out there. So compared to all the stars, it doesn't work for very many of them. So how else can we do it? And I'm going to give you some data here. We're going to use the stars Alpha Centauri and Spica. And we're going to look at their apparent magnitude and their absolute magnitude. So the little m is apparent magnitude. And big M is the absolute magnitude. And we should remember that apparent magnitude is how bright it looks from Earth, and absolute magnitude is how bright it really is. And remember, the smaller the number, the brighter. So Alpha Centauri has an absolute magnitude of 0.01, and Spica has an absolute magnitude of 0.97. And their absolute magnitudes are 4.38 and negative 3.55. And what we can tell from this is smaller is brighter. So this is how bright they appear. So Alpha Centauri appears brighter because it has a smaller number. So Alpha Centauri appears brighter as a small m. But Spica is much brighter, actually. It has a smaller capital M. Okay, negative 3.55. Remember, we said 6 was the dimmest star you could see, so in reality, Alpha Centauri is a pretty dim star. Why does it look brighter? It's because it's closer. And so how these vary is going to tell us something about the distance. And there's a mathematical formula for it. If we subtract the little m, the apparent magnitude, minus the absolute magnitude, we can plug in here and get d, the distance. We're not going to use the math formula. Okay, that's a little bit beyond this course. What we're going to do is I just graphed it here, and we're going to read it off the graph. Now, for some reason, this graph didn't print a couple of the numbers. See, here's 8, and they're going up by 2, 4, 6, 8, so this one's 10. And this is what's called a logarithmic scale. At first, it's going up by 2, and then it starts going up by 20, 20, 40, 60, 80. This would be 100. And then it starts going up, so it went up by 2, then it goes up by 20, then it goes up by 200. So 100, 200, 400, 600, 800. So that line right there is 1,000. Now, earlier in the notes, we had the following information about the star Polaris. The apparent magnitude, the little m, is 1.97. The absolute magnitude, big M, is 3.6. And what we're going to do is, this down here says subtract m minus little m minus big M. So for Polaris, it's going to be 1.97 minus negative 3.6. Now you can do this on your calculator, or you can kind of do this one step. A minus is a plus. So 1.97 plus 3.6. We're going to get little m minus big M is going to be equal to, so 5.57. All right, then all you have to do is look on the graph and see where 5.57 would be. Well, there's 4, there's 6, 5 would be right here, so 5.57 might be like right here. And then you just go up to the line, and then go across. And to me, it looks like it's somewhere between 100 and 200, maybe a little bit closer to 100. So we might say that the distance is 130, and the units is parsecs, which is a unit of distance. It's kind of like light years. It's a really big distance. All right, so you're allowed some leeway in this. Okay, you might have thought 5.57 was a little this way, estimate a little bit different over here. As long as you answered something between 100 and 200, I'd probably give you credit for it. So here's an example. So we'll do this for a few of them. So the first one is going to be 5 minus 3. We always do little m minus big M, so that minus that. And that's going to be 5 plus 3 is 8. So I'm going to make that 8. Then to estimate the distance to that star, I'll go over here to 8. I'll go up and go across. And that is 400 parsecs away. And let's go back. Remember, these are 10 right above the 8, 100 right above the 80, and 1,000 at the top. All right, second star. So this is, the second star is going to be 4 minus 5. 4 minus 5. 4 minus 5 is negative 1. So we'll put negative 1 here. All right, and then here's 0. Here's negative 2, so negative 1 would be about here. And I would go up and I'd go across. And I'd say that's about 6 parsecs. And then this one we're doing backwards. Okay, we have over here that the distance is 60. So now we go up to this column here and the distance is 60. And I go across 60 till I hit the line, and then I go down, and it gives me that the m minus m is 4. So this minus 3 is 4. So we could set it up this way. Little m, that's this guy, minus 3 is 4. So little m plus 3 is 4. So little m is 1. So hopefully that makes some sort of sense. And that is how astronomers find the distance to most stars that we see. Parallax isn't going to work. So we see how much the difference is between their apparent magnitude and the absolute magnitude. And the farther apart these numbers are, the farther away the star is going to be.